on our worksheet, problem number 1 of the homework said, let f of an x, and f of x means the same thing as y. It's just functional notation, right? So f of x equals 2x minus 3. 2x minus 3, is it linear, quadratic, or exponential? 2x minus 3. Linear, absolutely. Okay, so we have this. So complete the table, so we need to fill in the table that they're giving us. And they gave us -1, 0, 1, 2, and 3. Okay? And what these basically do is then create points, an x and a y value, x and y value. So let's plug in. So I get 2 times -1 is -2, -2 minus 3 is -5. If I go too fast on one of these, let me know. Plug 0 in, 2 times 0 is 0, 0 minus 3 is -3. Plug 1 in, 2 times 1 is 2, 2 minus 3 is -1. Plug 2 in, 2 times 2 is 4, 4 minus 3 is 1. Plug 3 in, 2 times 3 is 6, 6 minus 3 is 3. Okay, so we filled out the table. Find the average rate of change between 0 and 1. All that means is you're finding the slope. So remember this, and I went quickly through this, but this is the slope equation. And I'll give these to you, make sure that you remember it. But they're asking us what the average rate of change between 0 and 1 would be. So you're going to look here, and you're going to look here. Okay? So it doesn't matter which way you label it, x2, y2, or x1, y1, as long as you stay consistent. So I'm going to go this way. I'll go that way. So I'm going to go -1 minus 3, and 1 minus 0, which that's plus. So -1 plus 3 is 2, 2 over 1. That's my average rate of change. It's the slope. Okay, find the average rate of change between -1 and 0. Being it's linear, the average rate of change has to stay the same. The slope is always consistent. So for the next question, this is also the answer. Okay? And then find the average rate of change between 1 and 2. So if you went here and here, it's still going to be the same exact answer because the average rate of change is the slope. The slope does not change on a line. Yeah.
Would you just change that to 2? Or we have to keep it?
You can do it at 2. Absolutely. Keep it at 2. Yeah, you totally. 2 or 2 over 1. So, guys and girls, I can't emphasize this enough. So, a lot of times they will ask you, what is the average rate of change? And people are like, oh my gosh, I have no idea. Okay, it means you're finding the slope. We're talking like second week of the school year of slope. We're talking middle school math. Average rate of change. It's just another way of saying, hey, find the slope. Okay? You okay about that? All right, problem number 2. It says g at t is equal to t squared minus 1. G at t is the same thing as f at x. F at x is the same thing as y. Okay? Casey, got that way, man. You got your phone, or what do you got? Oh, I just saw you doing. Oh, okay, gotcha. Gotcha. All right, so number 2, we have g at t is equal to t squared minus 1. Now, g at t is t squared. Is it linear, quadratic, or exponential? Quadratic. Okay, so let's fill out our table. We have t and we have g at t, which is basically x and y. So I can just do this if you want. And then -1, 0, 1, 2, and 3. So again, these are just points. So if we plug it in, -1 squared is 1. 1 minus 1 is 0. 0 squared is 0. 0 minus 1 is -1. 1 squared minus 1 is 0. 2 squared, that's 4 minus 1, which is 3. 3 squared is 9. 9 minus 1 is 8. Okay? So that's how we figure that out. Does everyone feel okay about how I just plugged those in? Okay? Find the average rate of change. Now, being this is a quadratic, it's going to change because your quadratic, your parabola, as it curves up, it could get steeper. Okay? Or it could get all the way down to horizontal, all the way back up. So if now we're looking for the average rate of change, so the first one, we'll find it between 0 and 1. So we're looking here for this average rate of change. So we're going to find the slope. So I'm going to put the arrows this way. That's the way we'll go. Okay? 0 minus 1, 1 minus 0. That's positive 1, 1 over 1, which is 1 is m. That's our average rate of change there. Now, if I find the average rate of change between negative 1 and 0, so I'm going to now do this, and I'm still going to go this way with it. So by me doing that, I'm going to get negative 1 minus 0 over 0 minus 1. Whoa, there we go. So that's going to give me negative 1 on top. On bottom, that's going to give me positive 1. So my slope there is negative 1. Eyes up here. Is the slope for the green different than the slope of the blue? Yeah, one's positive, one's negative. The rate of change, the slope changes. Again, this is a calculus idea that we're throwing at you in algebra, and it's okay. Okay, it changes throughout. And then the last one says find the what? You good? Okay. And then last one, we're going to say, let's do that in red. We're going to find the average rate of change between 1 and 2. So here. Okay, so we're going to go this way. So I think we can do it. We're going to go 3 minus 0, 2 minus 1. 3 minus 0 is 3. 2 minus 1 is 1. So my slope here is 3. Look at our 3 different slopes. They've changed. That make sense? Yeah. The idea that's taken place here is this. If I were to have something graphed, and I'll just make this as a, let's say we have an XY axis and we've graphed this. Let's say it looks like that. I know that's not what our graph totally looks like. But this is the method that's taken place. Rate of change, I'm finding the slope here. 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 Okay? This linear, with respect to our quadratic, the linear slope changes as you go around. And that's what you're doing. Does that make sense how I said that? Again, it's a more complex idea, but it's very simple. And a lot of times on the ACT, when you see it, they'll say, "Hey, what's the average rate of change between this?" And you got people, they're trying to find the averages of stuff. You're like, "Oh, okay, yeah, these two, add them together, divide by 2, and that's one of the answers that they have listed, which is completely wrong. Rate of change is you're finding the slope. Okay, clear as dirt and mud. Dude, dirt's not clear, man. Okay, third problem. This is on the back side. Problem number 3. We have h at w. H at w is the same thing as f at x. F at x is the same thing as y. Okay, so I have 4 times 2, and 2 happens to be raised to the x power. Is this linear?
Yeah,
It's exponential. Okay? So the 2 is being raised to our unknown, our variable. Okay? So let's fill out our chart. So we have w and h at w, which is the same thing as saying x and y. Still with me? We have negative 1, 0, 1, 2, and 3. Again, these are just points. Okay, let's figure these out. So if I get 2 to the negative 1 power, 2 to the negative 1 is the same thing as 1 over 2. 1 over 2 is the same thing as 0.5. 0.5 times 4 is 2. Is that okay so far? Did anyone need me to go back through that? Okay. 2 raised to the 0 power. A number raised to the 0 power is 1. 1 times 4 is 4. Plug 1 in. 2 to the first is 2. 2 times 4 is 8. Plug 2 in. 2 to the second is 4. 4 times 4 is 16. Plug 3 in. 2 to the third is 2 times 2 times 2. 2 times 2 times 2 is 8. 8 times 4 is 32. We good so far? Does anyone need me to go back through that chart? So negative exponent, realize it makes it a fraction. If it makes it a fraction, it's a smaller version.
Don't forget -8 on the first one.
Wait, what?
On
Which value?
y equals -8 on the first one. So it would be -1, -8. That's what I got. But
Which value am I plugging in?
-1.
Oh, plugging -1 in?
Yeah.
Okay. So watch what happens. I'm plugging the -1 in there, right? So that's the same thing as 4 times 2 times -1, right? I'm not going 2 times -1. My exponent happens to be negative. A negative exponent means this part wants to move down. It wants to switch where it has been. If it's a numerator, it wants to move to a denominator. If it's a denominator, it wants to move up. So this portion right here is the same thing as saying this. Okay? And then 2 to the first power is just 2. 4 times half is 2. Make sense?
I didn't know I wanted to do that.
Yeah, so that's a great question. And it's an easy spot for people to get hung up, and we'll work it through. All right, so we're going to find average rate of change. So we're going to find the slope, y2 minus y1 over x2 minus x1. Get up there, x1. Cool. And we're going to find it between 0 and 1. So we're looking right here. So we'll go this way. So I had 8 minus 4. 8 minus 4 and 1 minus 0. So 8 minus 4 is 4 over 1, which is just 4. That's our average rate of change on the first one. Our next one, we're looking for the rate of change between here and here. Again, we're going to go this way. Still with me? So I'm going to get 4 minus 2, and then 0 minus minus 1. 4 minus 2 is 2. Minus minus 1 is plus 1. 2 over 1. So I have a slope here of 2. Is the slope with the green different than the slope of the red?
Yes.
Yeah, it's changing. That's fine. And then what's the average rate of change between 1 and 2? So I'm going to use these values. And again, we're still going to go that way. So I'm going to get, let's see if I can squeeze it in there. 16 minus 8, 2 minus 1. 16 minus 8 is 8 over 1. So I have an average rate of change. So notice the slope on each one of those values has now changed. Okay? Everyone feel okay about this? So when you see average rate of change, that means you're finding the slope. Okay? Let me ask you this. Could I find the average rate of change between here and here? Yeah, if I went this way, it would be 32 minus 2, 30. 3 minus minus 1, 4. 30 over 4, which is 15 over 2. And I purposely made it dotted because this is not a required question. So notice it still continues to change. So I can find it from the first to the last. It's still the same thing. Average rate of change, find the slope. Okay? All right, let's finish up this problem. Good shot. Okay, so for the most part, that's what our graph looks like. What was the highest elevation achieved? 15,000. So all the way up here is 15,000. So letter A, or number 4, 15,000 was our highest elevation in feet. Whoa. How fast are they ascending between 0 and 2? How fast are they ascending from here to here? So this is 0, 0, yes? What point is this then? What point is this? 2, 10. How fast are they ascending? We're finding the slope. We're going to go 10 minus 0 equals 10 over 2 minus 0, which is 5. So they are ascending 5,000 feet for every 1 hour of climbing at that particular rate. What was their average rate ascent on the interval from 0 to 5? So from 0 to 5. Okay? So again, we're going from here to 5. What point is that right there? 5, 15. Good. We want to know what the average rate is. So I'm going to go 15 minus 0 and 5 minus 0. So that's going to be 10 over 5. So that's also going to be 5 over 1. So our average rate from there is still the same slope.
Why is it 10?
Why is it 10? Oh, 15 minus 0, because that's, see, but it's 15. Sorry. That's 3. Man, I tell you, arithmetic's not my friend. Brenna, if you're going to just keep turned around, you're dismissed from class. Go on down to the dean. You're not doing anything. You're just turned around. I've seen the back of your head this entire lesson. No, I mean, look how you're sitting. I'm not going to debate you. We're not in speech and debate. You want to do that? Go take it over in the English department this holiday. Turn around, please. Thank you very much. So, on this one, we are ascending at 3,000 feet for every hour of climbing. Over what interval are they climbing the fastest? Where does it look the steepest? It looks like from 0 to 2, that's the steepest line.
Are you sure? I think it's from 5 to 15.
Oh, no, there's no ascent.
No, it's the same.
Like, man, I'm looking at the wrong picture. And then when are they descending? Our descent is here and here.
Is the descent at 15 or 14?
I don't like the color.
15. They're descending, well, they're descending from 6 to 10. That means we're dropping.
Yeah.
Here, we'll even make it work. So it's from 6 to 10. There you go. Burning the retinas. So from 6 to 10, they're descending. What was their average rate of descent between 6 and 10 hours? So that's 6, 15. And that is what? What's this point? 10, what? 0. Cool. So let's find that. 15 minus 0 is 15. 6 minus 10 is?
6 minus 10,
Negative 4.
And then, what does happen between 2 and 3? What is what? They're not ascending. They're just walking on level surface. They're not going up or down. Sweet? That is how we do the homework. Bless you.
Fine.
Gabe, I'm putting an extra one in here. All right. So let's run through these notes, see how we do. Let's see. X squared minus 7x minus 60 says factor the following. We're not doing anything. We're not solving it. We just need to figure out if we can factor it. So I'm looking for negative 60 is my magic number. I need to have alternating signs. Oh, I forgot 5 and 12. Which factors would work up there? One being positive, 5 and 12. Which one has to be negative? So I want to get negative. I think it's negative 12x, isn't it?
Oh, that's right. Sorry.
Common factor there is x, so I get x minus 12. So the factored form is x minus 12, x plus 5. Done. That's just traditional factoring, yes? Moving on. 8x squared minus 18. What do you know? Good. 2 goes in, so I have a greatest common factor of 2. This would be a 2-point problem. Right now you have one of the points. Why? Is there still more of a greatest common factor? What? There, you're almost there. It is perfect square. Is 4x squared a perfect square? That's 2x times 2x, right? And is 9 a perfect square? Is this what's in the middle? So this is what? Difference of 2 squares. Done. Okay. 3. Do I have a greatest common factor up there? A lot of people will say, oh, 3 goes in everything. 3 doesn't go into 20. Okay, then 9. Well, 9 doesn't go into 20. Do I have a greatest common factor up there? No, what's my magic number? How much?
180.
180, good. Are both signs going to be positive?
Oh, yeah.
Yep.
Yep. Sorry.
Yeah, baby. 2 and 90, 3 and 60, 4 and 45, 5 and 36, I think. Did I do that right? 7, 8,
Yeah.
9 and 20. Uh-oh. 10 and 18. Oh, shoot. We need something that's going to add up to the name. Did I forget one?
Yeah,
12 and what?
12,
12 and 15? Sweet. So 12 and 15, and that happens to be our go-to. So 12 and 15 will both work. So I have 9x squared plus 12x plus 15x plus 20. What do I have in common between those? 3. What else? X. Good. Good so far? What do I have in common between these? 5. So plus 5. What's my factored form? Thank you much. 3x plus 4, 3x plus 5. TJ, good job pulling that 12-15 going. Love it. You okay? Reese, you good?
Yeah, I thought we were gonna. Isn't there like more to be done?
I don't have to solve it because it's not equal.
Oh, all right then.
Is that cool?
Yeah, that's fine.
Yep. All right, next one. It says identifying the three models, linear, exponential, quadratic. So a linear model, f at x, which means the same thing as? F at x means the same thing as y, equals mx plus b. So this is your, okay, some important terms. It's a line. A line is straight. You need two points to identify a line. A slope, well, the slope equation goes along with rate of change. So when you see rate of change and slope, you can interchange them. Okay? The slope equation is the same no matter what. So that's our slope equation. Usually we use the letter m to deal with slope. The y-intercept is where it crosses the y-axis. The x-intercept is where it crosses the x-axis. Pretty simple. Okay? Problem number 1. Does anyone need me to go through problem number 1? Or plug in the values in. So if you want to complete the table, I'll just verbally tell you. If I plug negative 3 in, I get negative 2 times negative 3 is 6. 6 minus 4 is? 2. Cool. If I plug negative 1 in, negative 2 times negative 1 is 2. 2 minus 4 is? What? What is it? Negative 2. Plug 0 in. Negative 4, good. So negative 2 times 0, and then 0 minus 4. If I plug 1 in, negative 2 times 1 is negative 2. Negative 2 minus 4 is? Negative 6. Then if I plug 3 in, I get 2 times negative 3. Or excuse me, negative 2 times 3 is negative 6. Negative 6 minus 4 is? Negative 10. So can someone repeat back? At negative 3, what value did we have? 2. At negative 1, what value did we have? Negative 2. At 0, what value did I have? Good. At 1, I had what? Negative 6. And at 3, I had? So if I graph those, they should fall to be a straight line, yes? So let's graph it. Have a graph up here? All right. At negative 3, I was at what? Negative 2, thank you. At negative 1, I was at what?
Negative 2.
No,
You got
so the
negative
first
3
one
or
was
2.
positive. The first one was positive.
No, it's positive 2.
Oh, this was positive 2? Oh,
Yeah, the next one is negative 2.
okay, hang on. We'll get that. So at negative 3, I'm at positive 2. Is that what you told me? Yeah? Okay, and at negative 1, I'm at what?
Negative 6.
Negative 2? At 0, I'm at what?
Oh, I'm sorry about
What? At 1, I'm at what? At 3, I'm at what? 7, 8, 9, 10. That forms a straight line. Let's just pretend I can draw straight. No judging. What is the y-intercept? It's right there. What's the y-intercept?
Negative 4.
Negative 4. Cool. What is the x-intercept? Negative 2, 0. Cool. What is the rate of change from negative 3 to 0? So negative 3 gave us negative 3, 2. And 0 gave us 0, negative 4. Correct? So rate of change, negative 4 minus 2 is equal to negative 6 over 0 minus 3. Positive 3, so that's negative 2. That's my rate of change. The rate of change, because it's a straight line, what do you know? It's linear. What do you know about the rate of change of a linear? It's going to be the same. So it doesn't matter if I go from here to here, or from here to here, or from here to here. It's going to be the same rate of change, which is our slope. Okay? Feel good? Given the table, write the function. Ooh, given the table, write the function, really. So x and f at x. F at x is the same thing as what? Bless you. Y, good. So that's the same thing as y. So I have -2, -1, 0, 1, 4, 4, 5, 6, 7, 10. Okay, for example 2, this is going to be a linear model. So the things we have to remember, find the slope first. And then the one that you have to remember is use point slope. That's one we haven't seen in a while. And then you solve for y. Okay? So let's pick these and these. Sound good? Find the slope. I'm going to go this way. 6 minus 4. 0 minus 2. 2 over 2 equals, that's my slope. Now let's pick this for x1, y1. So I'm going to go y minus 6 equals 1 times x minus 0. Distribute. Add 6. There's my equation. Okay, it's been a while since we've done that, but make sure we have it down. Cool. Exponential model. Which letter has the exponent tagged with it up there?
B.
B. A is not influenced by B. A is just the growth factor. Okay? So, some terms. Exponential growth means you're getting more. The graph exponential growth would look something like this. Okay? You're getting more. Is exponential growth good? Sure. Is it bad? Sure. What do you mean? Well, it's good when your money's doing it. It's bad when your fever is increasing. Okay? Exponential decay. Means we're going less. Exponential decay graph looks like this. Exponential decay could be good. Okay? You had an infection. Your white blood cell count is dropping, so the infection's going away. That's good, exponentially. Exponential decay is bad when you're like the national government and you're spending more than you're bringing in, and it creates something called the national
Debt.
debt.
Debit.
Okay? Federal government is so easy to spend someone else's money, isn't it? Someone else is paying. Don't you think it'd be easy? Someone said, if someone took you over to the store and said, buy anything you want in that store, no big deal. You wouldn't have a problem going in and buying everything in that store, right? Because it's on their dime. And then let's say this is some rich person that you know, or you just met. Okay? Now, you go to that same store going, okay, I got $12. No credit card. You're going to probably be a little more frugal about money. You want to know what gets people in trouble real quick? Credit cards. Okay. You get to college, you know what's fun? There's all these credit card vendors that are standing there. Hey, you want to apply for a credit card? It's easy. We just need your signature and address. Start spending, you'll be fine. All of a sudden you get that bill in the mail and you're like, oh, I spent $3,600 this month. Wait a minute, Mom, Dad, would you spend $3,600? Well, Julie wanted to go to the store, so we went to the store. And then I went to Starbucks, and then McDonald's every morning. And then it rings up quick. And all of a sudden you realize that credit cards aren't always a good thing. Hopefully, there's a reason why the first credit card you get probably has a $500 credit limit. Okay? The federal government probably got in place saying, hey, that kid expression costs no more than $500. If it was unlimited, you gotta go buy a Tesla. Here you go, sir. You got 30 days to pay it off at 28% interest if you don't do it. Y-Intercept. Y-Intercept happens on both. X-Intercept doesn't always have to happen. I'll put a question mark. It doesn't always have to happen. A horizontal asymptote? Yes. Horizontal asymptote is the value, the horizontal line that you're approaching closer and closer and closer. A lot of times it will be your x-axis, but it doesn't have to be. Okay? You feeling good? We're live and doing fine. Oh, signs. Anyone know the song? By Tesla? Tesla did a remake of it. Complete the table. F of x is the same thing as what, George? F of x is the same thing as what?
Y on X.
Y. Good. Thank you. -2, -1. Oh, jeez, I'm going too quick on myself. Almost done. This will be our last one. 0, 1, 2. All right, ready? Plug -2 in. Angelo.
Yeah.
If I plug that -2 in here, I get this, which is the same thing as this, which is the same thing as this. So what's 1/4 times 1/2? Anybody? 1/8. Good. Okay, Angelo, again. I got a negative exponent. I'll plug it in. So I get 2 to the -1. That's the same thing as 1/2 to the first, which is the same thing as half. Half times half. Anybody? Half times half? 1 times 1, 2 times 2? Good. If I plug 0 in, 2 to the 0 power is equal to 1. 1 times 1/2. 1/2. Good. Plug 1 in, 2 to the first power is 2. 2 times half. Plug 2 in, 2 squared is 4. Half of 4 is? These are the things I'm going to graph now. Let's extend the page a little bit. Come up a little bit. Ready? Let's see if we can make this work. At -2, this is 1 right here, I'm at an 8. At -1, I'm at a 4th. At 0, I'm at half. At 1, I'm at 1. At 2, I'm at 2. Here's what this graph looks like. It's coming down by the x-axis. What is the y-intercept? It's right here. It's at 0, half. What is the equation of the horizontal asymptote? The horizontal asymptote, does it look like it's going to cross this line? No, it's not going to go to the negative side. My horizontal asymptote is equation x equals 0. No, jeez, y equals 0, I'm sorry. That's what this this line will be y equals 0. It's a horizontal line. What is the rate of change? We're just finding the slope. What is the rate of change? We're just finding the slope. What do you notice between E and F? I'm sure, I think it's D minus C, I think. They would probably be different. Is G at X an exponential growth or decay? Growth or decay, what do you think? Growth. Okay? The last one is a quadratic, which we will deal with later. Homework is page 137, 139. Okay? They're up here in these baskets. You need to come take a picture of it. Good deal.